Hello, this is Ryan again, back with yet another wacky physics video, and today we have a very interesting problem. In this problem, we have to look it up again because I forgot. Alright, so I am back, this time with the problem. So we have a skater girl. She is going down a ramp that has a 10-degree incline. And they only give us two things, her initial velocity and her final velocity. And her initial velocity is 5 meters per second. So she starts off going down this ramp pretty fast. And she goes down this ramp, accelerates, and she ends up with a final velocity at the bottom of the ramp, 11 meters per second. And our job is to figure out how much time it took for her to go down that ramp and what is the length of that ramp. And we can do so with the following kinematic equations. That is, speed final, or position final, is equal to initial position plus the initial velocity times the change in time, plus half the acceleration times the time squared, change in time squared. And we can also use, these two, which is probably the ones we're going to end up using, which is velocity final is equal to velocity initial time, or plus acceleration times change in time. And then, well, you can read. I'm sorry, I don't even know why I read these out. But we get our knowns, and we try to figure out our unknowns, which in this case is just time, because we're going to use this second equation right here. So our final is known. It's 11 meters per second. Our initial is known. It's 5 meters per second. And our acceleration is known. Well, it's supposed to be known. We have to calculate it. The way we calculated it is by taking gravity, which is 9.8, and multiplying it by the sine of 10 degrees. Now, the reason why we multiply it by the sine of 10 degrees is because since she's going down a slope, we need to figure out her acceleration in the x direction relative to that slope, which is going to be 10 degrees. And you can figure that out by doing a little bit of trigonometry and noticing that you're going to want to find this vector, which is going to be equal to the hypotenuse, which is 9.8, times the sine of 10 degrees. And when you do that, you get 1.7 meters per second squared. So that's your acceleration. And then at that point, you just solve for time, and you do that by isolating, first by subtracting 5 meters per second to get 6, and then you divide it by the acceleration, and you should get time is equal to 3.5 seconds. So what this number means is it took her 3.5 seconds to get from the top of this ramp to the bottom. And I guess that makes sense. Now the next part of the question is we have to figure out what's the length of this ramp that she's going down. The way we do that is by using the other kinematic equation that was provided to us, which is right here. V final squared is equal to V initial squared plus 2 times the acceleration and the change in position. Now we know everything in that equation but the change in position, which is what we want to find. So this is a very, very convenient equation to use for this problem. So we set it up. We know final position, final velocity, it's 11 meters per second squared. And then we know the initial velocity, which is 5 meters per second. So we square that as well. And then we add our acceleration in the x, or I'm not in the x, but in relative to the angle, which is 1.7 meters per second squared. Multiply it by 2, and then we have our unknown here. So it's just another solve for x, which is in our case delta s. And we end up getting this equation, which is 11 squared minus 5 squared over 3.4, which turns out to be 28.2 meters. And this number means that it is the length from here to here in meters. So Hopefully you learned something from that video. If you did, leave a like, maybe subscribe, and I'll be back next week with another physics tutorial. Thank you.